The cosmic question, are we alone in our understanding? The universe stretches out, it is immense beyond imagining. Stars like dust motes fill the cosmic dark, galaxies swirl in an endless dance. Amidst this grandeur, what are we? Is our brief spark of consciousness significant, or are we just a fleeting cosmic accident? These are ancient questions. They echo in the human heart. We long to know our place. We search for deeper meaning. New tools can offer new perspectives. Telescopes showed us a vaster cosmos. Microscopes revealed worlds unseen. Now a new kind of tool emerges. It is the quantum computer. Google's Willow is one such machine. It promises to unlock secrets hidden in the very fabric of reality. It might change how we see everything. It could reshape our understanding of existence. The quantum realm is a strange place. It defies our everyday intuition. Particles can be in many places at once. They can be connected across vast distances. It's a world of probabilities, not certainties. This is the world Willow explores. The journey into the quantum age has begun. Google did not build Willow overnight. It was a journey of many years. A dedicated team worked tirelessly. This is Google's quantum AI team. They are brilliant scientists and engineers. They share a bold vision, a vision of powerful quantum computers that can solve the world's hardest problems. This dream fueled their long efforts. Their persistence has now borne fruit. The path was paved with earlier machines. Google built processors like Sycamore. Sycamore achieved a key milestone. It performed a task faster than supercomputers. This was called quantum supremacy. Each new chip taught them valuable lessons. They learned about qubit design. They learned about controlling quantum states. Willow builds on all this knowledge. It represents a new generation of power. The goals for Willow were ambitious. The team aimed for more qubits, but more importantly, better qubits. Qubits that are more stable. Qubits with lower error rates. Connectivity between qubits was also key, allowing them to interact in complex ways. These improvements are crucial. They are steps towards truly useful machines. Willow embodies these advancements. Willow is a marvel of engineering. What makes Willow so special? It's not just one single thing, it's a combination of factors. The number of qubits it possesses, the way these qubits are connected, how long they can maintain their quantum states. This is called coherence time. Willow pushes these boundaries forward. It represents a significant leap, a leap in quantum computing capability. It stands as a new benchmark. We hear about quantum advantage. This means a quantum computer doing something useful, something a classical computer practically cannot. Willow has demonstrated this power. It tackled a specific complex problem, a problem designed to test its limits. The results were astonishing. It solved it in mere minutes, a task of immense difficulty, a task that would stump even giants. Consider the fastest classical supercomputers. For them to solve the same problem Willow did, it would take an immense amount of time. Not days, not years, but potentially eons. Some estimates suggest thousands of years. Willow did it before a coffee could cool. This is the scale of its power. This incredible speed is not just about being fast, it's about doing things differently. Willow doesn't just crunch numbers faster, it thinks in a quantum way. Echoes of other worlds, quantum mechanics, and parallel possibilities. Quantum mechanics is famously weird. It describes a world unlike our own. One of its strangest ideas is superposition. A particle can be in multiple states at once. Imagine a coin spinning in the air. It's neither heads nor tails until it lands. A qubit is somewhat like that, but it can be both 0 and 1 simultaneously. This is fundamental to quantum power. It allows for massive parallelism. When we measure a quantum system, things change. The superposition collapses. The particle chooses a definite state. But why does this happen? What does this collapse truly mean? One interpretation is the many worlds interpretation, or MWI, proposed by Hugh Everett III. It offers a radical explanation. It suggests the collapse is an illusion. All possibilities actually happen. The many worlds interpretation is mind-bending. It says that every quantum measurement causes a split. The universe branches into multiple versions. In one universe the particle is spin up, in another it's spin down. Each possibility becomes real, each in its own separate parallel universe. An ever-expanding tree of realities. Our reality is just one branch. The guardian qubit Willow's breakthrough in error correction. Quantum computers face a formidable enemy. This enemy is error. Qubits, the building blocks, are incredibly fragile. They are easily disturbed by their environment. This is called noise or decoherence. It causes their delicate quantum states to corrupt. This leads to errors in calculations. For a long time, this was a major roadblock. How can you trust a computer prone to so many mistakes? This challenge had to be overcome. The solution is quantum error correction. It's a clever set of techniques. The basic idea is redundancy. You use multiple physical qubits. These physical qubits work together. They form a single, more robust, logical qubit. If one physical qubit gets an error, others can detect it. They can then correct it. This protects the quantum information. It's like having multiple backups for your data. Willow has made a huge leap here. Google's team demonstrated a significant breakthrough. They showed that their error correction codes work. They created logical qubits using Willow. These logical qubits were more reliable. They perform better than the individual physical qubits. This is a critical milestone. It shows that errors can be actively fought and that they can be suppressed effectively. Simulating the universe, Willow as a window to fundamental truths. The great physicist Richard Feynman had an idea. He said, "Nature isn't classical, damn it. If you want to make a simulation of nature, you'd better make it quantum mechanical." He proposed using quantum systems to simulate other quantum systems. This is a powerful concept. Classical computers struggle with this. Simulating quantum mechanics is hard for them, but a quantum computer is naturally suited for it. It speaks the same language as nature. Willow is poised to be a powerful quantum simulator. Imagine designing new medicines or creating revolutionary materials. These tasks involve understanding complex molecules. Molecules are quantum systems. Willow could model their behavior precisely. This could accelerate discovery dramatically. Finding new catalysts for green energy, designing more efficient solar cells, the practical applications are immense. It could transform many industries, but the potential goes even deeper, beyond these vital practical uses. Willow could simulate fundamental physics. It could help us explore cosmic mysteries. Beyond the veil, Willow and the nature of reality. Albert Einstein was famously uneasy. He disliked the randomness in quantum mechanics. He said God does not play dice with the universe. He suspected something was missing. Perhaps there were hidden variables, underlying deterministic rules that we just couldn't see. These rules would make quantum behavior predictable if only we knew what they were. This was a deep philosophical debate. It questioned the completeness of quantum theory. Then came John Bell, a brilliant physicist. He devised a mathematical test, Bell's theorem. Experiments like those by Alain Aspect followed. They tested for these local hidden variables. The results were clear. Local hidden variables, as Einstein envisioned, don't exist. Quantum mechanics seems inherently probabilistic. The universe does seem to play dice. The weirdness is not just our ignorance. It appears to be a fundamental feature of reality. Willow's performance reinforces this. It operates flawlessly according to standard quantum mechanics. Its calculations, its power, all stem from these principles. There is no evidence from Willow, no hint of underlying hidden variables. It doesn't peel back a curtain to reveal a simpler classical world. Instead, it confirms the strangeness. It shows that the quantum rules are the rules, at least at the scales it operates. This deepens the mystery in a way. So, did Google's Willow glimpse beyond reality? Not in the sense of seeing other dimensions or spirits, but it does something perhaps more profound. It forces us to confront the nature of reality.